Alright, so I'm going to talk about my senior project today, and first, um, I'll open the Elgato software. So what this software does is it takes a signal that's fed through it. It comes through the Nintendo Switch, so that's kind of the only way to get it to show up on the computer. And as you can see, this is what's coming through the Nintendo Switch. Okay, so next I'm gonna open up my input viewer. This is some third-party software that I found through a bit of searching online. It took me a while to find this because it's not really normal for people to do this. So basically what this does is it shows the inputs that are coming in through the controller. And the reason this is really important is because it allows me to collect data a lot easier. So basically what I ended up doing is I used image recognition to detect what's being pressed here. So if it's pressed left, it'll see that it's being pressed left. If I press the jab button right here, it'll detect that, the A button, the L button, stuff like that. So I was able to make it so that if it detects jab, it takes screenshots for jab, and it stores it in a folder labeled jab, so I can use that later for training some models. Okay, so let me go ahead and open up the project. So it's divided up into two separate sections. You got the part for collecting training data, and that's kind of the part that I just showed you right now. And then after I go through that, I'll go through the part for interpreting the image and applying the models that I train here. So let's go ahead and run this. Okay, so we came into an error here, and the reason for that is because I'm not in the right folder, so I'm just gonna go to the collect training data folder and retry that. And here's the window that detects screenshots, so I'll just bring this over to the side so you can see everything. I'll do the jab first. So here's a bunch of images that I already saved. They look weird because I added the image filter. So first I tried doing it without any image filter, and that was not working well. So I ended up adding a filter to try to like filter all the noise, and so it just detects the important stuff. So this is what's important. It detects the jab right at this frame, and yeah, so here's all the images I've already collected. So I'll just click jab and see if it works. Okay, there we go. Yep, and it seems to be working. So the problem I ran into here is while it works okay, you know, it gets some jabs. Sometimes it gets bad images, so I'll just have to go through and delete those afterwards. What I'm gonna have to do to like really take this project to the next level is, instead of relying on image recognition to get the inputs, I'm gonna need to like write an actual program to get the inputs. So the code for this is open source, so I'll have to go through that and figure out how they get the inputs and display it on this, because getting it from actual code as opposed to image recognition would help streamline things a lot, and I think I'd be able to get it a lot more frame perfect and maybe not even have any bad data when I when I store the images, and that would be huge. That would make things go so much faster in getting good data and training data. But I kind of ran out of time in this case, so I wasn't able to do that. So you see the jabs working. Let's do grab. So my grab is the A button. So I click A, and yep, you see it stored some images, but these are bad images because it has this thing here. So I'll just delete those. So that's how I do the collecting data to train. Another important part of this is, let me just show you. So how this works, it gets a screenshot and it detects if buttons are pressed, and then it detects if B's in the button pressed. If it is, then the B is for the jab button, so it saves a jab in the jab folder. But then I also created this function. So Mario.jab holds the frame data. So basically what the frame data is how many frames does the jab last. Jab's probably like frame 1 to 3 or something like that. So that tells me how many screenshots do I need to take, so that I'm only taking screenshots during the move, and I'm taking screenshots of like all the important stuff of the move, because some moves last like 20 frames, some moves last 1 frame. So that allows me to take the right amount of screenshots. To find the frame data, it's super easy. You just search Super Smash Bros. Ultimate frame data right here. So I'm using Mario, there he is. And you can see there's lots of different types of jabs. So this is all just from the B button. Jab 1, it's active on frame 2 to 3, so that's about the frames I tried to set in the program. And this is the jab that I'm doing image recognition on. I'm ignoring these jabs because all I need is jab 1, and if I recognize jab 1, I can tell he's doing a jab. But yeah, it goes through all his different moves. This one's active on frame 15 to 17, so that's way different than jab 1. And I stored all the frame data in the utilities folder. Nope, not the utility, in the character folder. Frame data. So this is the frame data for Mario. I put jab at frames 1 to 3. I think it's actually 2 to 3, but I guess 1 to 3 was getting better results for me. Grab is frame 6 to 11. Jump is frame 1 to 5. Stuff like that. So right now I'm not detecting inputs, detecting all the inputs. I'm only detecting some of them. So I only collect data for some inputs at a time, and the main reason for that is just because doing all of them slows down the program too much. And that's another reason why I should be getting inputs from just the code and not from image recognition, because image recognition is too slow. But if you want to change the inputs that you're detecting, you just go into the utilities folder and you got an input reader. So vision A, this detects if the A button's pressed, and that goes into controller image, and this detects if the A button's pressed. So that's right there, it detects for that, but with the brighter color like that. I'm gonna go ahead and stop this program. Just by pressing Q, you can stop it when you highlight the window. Okay, this is for the B button and so on. And this is the important part. This is where it does the recognition. So right now I have it only detecting A, B, Z, L, and R, which are some of the more important buttons. And these are basically the weights that I had to do to get it to detect each one accurately and not have false positives and stuff. And this detects if only one button is clicked. So that is used right here. So how it works is if I'm pressing B like that, I'll show you. it just says jab. But if I'm pressing over and then B, it does side tilt like that. So if I want to collect data from jab, I gotta check if only one button's being pressed. Otherwise, it's gonna store a bunch of side tilts in the jab folder. And that's true for a lot of different moves. So yeah, this one just checks if the buttons are clicked, if A is clicked, append A to the clicked buttons. And that's the input reader right there. If you want to see the frame rate, you just uncomment that out, run the program again, and we're getting like 10 frames per second, so that's okay. It's not the best, but it's doable. I like leaving it uncommented because now when I click like B, it'll tell me it got the B input. So that's what I've been going with. And right here is to exit the program if Q is clicked. So that's basically it for that's the important parts for the data collection. So what I'm going to go over now is how to train the model with the data we collected. So I think I'll train the neutral special model. So this is the one that does a fireball. And I'm just going to clean this data a little bit. And some of these don't have fireballs in it. Like those. So just delete those. These ones all look pretty similar, so I'm just going to delete all of them. Because you don't want data that's too similar, because that'll make the model like overcompensate for certain things, and it'll only be able to detect certain things. It's not very flexible or robust. But yeah, all of those look okay. And I got this commands for training. I'll just put that in there. And this kind of goes through everything we need. So I'm doing the fireball, so that's neutral B. They're all basically the same, but just with slight modifications. And this brings me to something you need to install first. It's a different version of OPENCV, because the current version, they haven't ported over like these training tools yet, because they're focusing on image recognition, stuff like that. So how you install that is you search OPENCV Windows install. Here it is. And I'm just going to get the latest version of 3.4. Download that. Yeah, I think 3.4 is the version. Wait, it downloaded 4.5. Yeah, I need to click here to download it. There we go. So I'm just going to run that when it installs, and it'll kind of like extract the files. So yeah, that popped up because I already had the folder in there. So I'm just going to rewrite it all to show the process. Okay. And there you go. That's what it extracted. What we're going to need is in build, the file path's right here, build x64 v15 bin, and the first command we'll be using is OPENCV annotations right there. And I just put this OPENCV folder in my projects folder, so I'll just use this one. And then you do --s annotations, and then this is what you want to name the file that you're creating. What you're creating is a file that has goes through all the positive samples, and then you're going to highlight the positive image in the positive samples. I'll show you. And this is where you're pulling the images from. So you're just going to be in screenshots, and then specials and neutral special, because that's the one I want. So just put this in here, run it, boom. Okay, so you click at the top corner and click at the bottom corner, and then to confirm, you press C if that's the image you want to go. And then to go to the next one, you press N. C, N, C, N. Okay, so this is different because there's two, so you just highlight the first one, click C, and then go ahead and do the second one so to get both positive samples. And this might take a while, but you want to take your time doing it because, I mean, if you already spent all that time collecting the data, you want to just invest some time in labeling good images. Alright, so now that's done, it saved the thing in here. So what you got here is the path to the image, and then these are the vectors that you drew, and on this one we drew two, so these are the vectors for the first one, that's the second one, or something like that. Okay, now we need to create a VEC file from that positive image. So it's going to be in the same folder, except in this case we're going to use OPENCV create samples. And this is the text file that we just created. H and W is the max number of pixels that you want it to be able to recognize. So I have it going in 24 pixel sections, which is a pretty normal amount. The bigger this number is, the more accurate your training model can be, but you can also overtrain it, and also bigger numbers take longer. So 24 takes a reasonable amount of time to train. This number, I think it just has to be bigger than the number of positive samples that you have. So here we have like 100, so like anything over 100 will work. It doesn't matter if it's way over 100 though. And this is what you want to name your VEC file. So let's run this. It's usually faster, so something must be going wrong. Yeah, let me just try redoing this. I think the problem might be I didn't label a positive image on all of them because I was just going through it showing how to do it. So you can see on all these it just has 0 for the vectors, and that might be what's causing it to not work well. So I'm just gonna go through and fix this and relabel them. Alright, so I went through and relabeled all the images, and this is what I got now. There's still a few with 0 because there were some that didn't have any good labelings, but we got 148 samples, so let's try running this create samples command again, see what happens. Alright, so it looks like it worked. It created 161 samples, so that just means I labeled 161 objects, because in some of the images I labeled 2 objects. Okay, so let's go back to here. We just ran this command. The next one is to train the model. Okay, anyway, so here you pass in the file you just created with the create samples command, and this is another text file that we still have to create. This is for all the negative images, so let's go ahead and create that. You do that in the Cascade Utils file under the Utilities folder. and I'll name it fireball neg. And so in this, I'm just drawing from 3 different folders to pick out the negative images. I'm getting all the jab images, the shield images, and the jump images. You can do more if you want, but that's just what I'm doing. Probably more is better. And I commented out the neutral special images because those would be the positive ones, and I only want negative. So I just run that, and it created this file, and we got like over 400 negative images. And the more data you have, probably the more accurate it's going to be. Okay, so we got that. The width and height, this has to be the same as it was in the previous command. Number of positive, this has to be less than the number of samples created, so I'll do 150. Num neg, that has to be, I think, less than the negative number of negative. Some people say the best amount for num neg is half the number of positives, so 75. Some people say it's twice the number positive, so 300. The more negatives that you pass in, the more, I guess, picky the model's going to be. So if you want less false positives, then do a higher number of negatives. I'm going to do, I'll just do 150. I mean, you can do like 1,000 or something way more than number of positive, but I'll do 150 because I don't want it to take too long training. Number of stages, 10 is a good number to start out when you only have like 150 positives. The more stages you have, the more picky the model will be once again, but more accurate as well. These 2 commands just allocate RAM to training, so it might help it train faster. I allocated 12 gigabytes in total, 6 to each. And my computer has 16 gigs of RAM. Max false alarm rate, set that to 0.01, and min hit rate 0.99. So I mean, you can set this to whatever you want, but the lower the number is for max false alarm, the more picky it will be, and the higher this is, once again, the more picky it will be. So it just depends on how you want to train it. You want it to get false positives, or you want it to be like super picky and not very robust. So I'm gonna open a command prompt window because I don't want it to take over my Visual Studio Code while it's training. Okay, and we just put that in there. It should train, but as you can see, we ran into an issue. So the issue here is I still have training files in here from before, so I'm just gonna delete these and then run that. Okay. So this shows some data about the training. I'll wait till it slows down a little bit to discuss it further. Okay, so basically you have the hit rate and the false alarm rate, and I believe the hit rate is if it can find an image that matches it, and the false alarm rate is images that match it, that it thought matches it, but didn't actually match it. So as you see, as it goes down in the layers, the false alarm rate will go deeper, and how this works is it'll keep on adding layers until it reaches my desired max false alarm rate, which is 0.001. So that's why this does 18 and that did 13. It just goes until it reaches the number. And the acceptance ratio tells you like how picky your model will be. Some people say that if you get like more than 4 zeros after the decimal, which this already does have, then it means you're overtraining your model. I personally don't think so in this case because I want to be really picky with like what it recognizes, and I think it's okay that it's really picky because it's a video game and a lot of the animations are going to be exactly the same without as many variables as you would have in the real world. So yeah, I'll just let that finish training. Hopefully it doesn't take too long. Alright, so it's done training. It just took 7.5 minutes, so that's pretty good. So in the command, you can see this part I didn't explain. It is where you want to save the files, and I saved it in this folder right here. So I'm just gonna take this, copy it, and go down to the interpret images, and I'm gonna paste it right there. I'll put it in Cascade Models, close all this stuff, and then I'm gonna open up the main file for this. Let's see, so I already have this model trained for detecting the fireball or neutral B, which are the same thing. So I'll try this one out first. Okay, there we go. So now it tracks the fireball. I'm not sure what this is. I think it thinks that's jab for some reason. Okay, we can see it can track jab pretty well. I'll have to figure out what that is. So now let's try the new model, which is just called Cascade right now. What was that? Let's try this again. Okay. Yeah, so I think I like the old one better because this sometimes recognizes Mario face as a fireball for some reason. I don't think the old one was doing that. But yeah, basically all that to say, that's just how you train the model off your training data. And next I'm going to talk more about this part of the program, visualizing it, and so we'll get into that next. Alright, so something I wanted to try first is increase the number of stages here. So I believe if I just increase this to 15, let's try 12 first, then it'll just train the next 2 stages and it won't have to train the first 10 since I have all the same settings. Yep, so it's starting at stage 10, so that's a nice thing. But I want to try this first to see if doing more stages will increase the accuracy and decrease the false positives for the neutral B. Alright, so I tried training it up some more stages, and that did increase the accuracy, so that's good. Alright, so now I'm going to show you the tracking feature in action. So I have this little recording that I took. You can use the tracking with a recording or a screen capture, but since the FPS is low, if you use the screen capture, it'll look kind of jumpy. If you'll use a recording, it won't be jumpy, but it'll just move slower. So we're going to opt for that option right now. And if you want to switch, you'll just uncomment out this line. So let's give it a shot. Okay, so first we select Mario and then you can hit the space bar and boom, there we go. So yeah, like it's even able to track him when he's spinning around in the air, and it's able to detect the fireball, so that's good. It detects the jabs, the shield. So here's an issue I ran into. Sometimes it detects the fireball on the shield. I guess it's because it has a red color. And you can see here at the end it keeps track of all the stuff it counted. So this can be really important data when trying to analyze playstyle, like how much does he jab, how often does he shield, which shielding is an important habit to notice. How often does he use fireball, and so yeah, that's how the tracking works. So yeah, that's gonna conclude my summary of this project, and I think it was a fun project, and I learned a lot. I would say if I were to start over or keep on working on it, I'm definitely going to look into using TensorFlow for the image recognition, because I think that could have a lot of potential to make things easier. And also I need to figure out how to get